I want you to imagine something for a minute. You're out in the middle of the Sahara Desert. Just, sand for miles.
Okay.
You pull a pair of dice from your pocket, you roll them. Double sixes.
Lucky roll.
Okay, lucky roll. Now you get in a Jeep, you drive 1,000 miles east, get out, roll them again. Double sixes. You fly to the moon, roll them again.
Okay.
Double sixes.
At that point, I'm checking the dice. Or I'm assuming it's some kind of magic trick.
Exactly. You'd assume the game is rigged, that there's some, invisible connection making those dice land the same way every single time.
Right.
Now, just take that feeling and scale it up to the size of the known universe. Because we're talking about quasars, these massive, glowing galactic centers that are separated by gaps so wide, light takes billions of years to cross them.
And just to be clear about the scale, we are talking gigaparsecs. These are distances where, under standard physics, two objects shouldn't even know the other one exists. They're completely causally disconnected.
They're strangers. And yet the data we're seeing suggests they're doing exactly what those dice did. They're aligning, pointing in the same direction. It's like the universe is just rolling double sixes over and over again.
And that impossible part is really why we're here today. This isn't just some weird little coincidence. This is a potential violation of the standard model of cosmology.
If it's real.
If this alignment is real, yeah, our current understanding of how everything formed is, well, incomplete is the polite word.
I think broken is the word I'd use. So today, we're diving into a document that claims it has the solution to this impossible puzzle. And I have to warn you, the solution they propose is, in a way, almost scarier than the mystery.
It definitely is a mind-bending read. The paper is called The Geometric Inevitability, Structural Orientation and Large-Scale Quasar Coherence. It's from Heiko Grimberg and the Nexus AEBE team at the UCF Research Group.
And we have to flag the date, right on the front page, January 29, 2026.
Which makes this what they call a pre-data lock paper.
Explain that. Why is that so important? I mean, it just sounds like they published a paper.
Well, it's sort of a high-stakes gamble in the world of science. Usually, you get your data, you look at all the dots on the graph, and then you try to draw a line that connects them.
You build a theory to fit what you already see.
Right. Hindsight is 20/20.
Yeah.
But these authors are doing the exact opposite. They are planting a flag in the ground before the data arrives.
From the Euclid telescope, right?
Exactly. The Euclid survey is mapping the dark universe right now. And it's going to release this huge definitive data set between 2026 and 2028. Grimberg's team is basically saying, here's what you're going to find. If we're wrong, our theory is trash. If we're right, you have to rewrite the textbooks.
So they're betting their reputations on a specific prediction.
A very specific prediction. A specific number, even.
I love that kind of confidence. But okay, before we get to their solution, which involves some wild stuff like Lattice-14 and chronofractals, we need to understand why the current physics is failing so badly here.
Right. It all comes down to a core idea called the cosmological principle. Specifically, the concept of isotropy.
Isotropy. Okay, break that down for us.
In simple terms, it just means the universe looks the same in every direction. There's no special up or down in space.
Okay.
And the standard model assumes that the vacuum of space is, well, a fluid.
A fluid, like water.
Think of a cup of black coffee. If you stir it with a spoon, you get all these swirls and little whirlpools, right?
Sure.
But those swirls are random. A little eddy on the left side of the cup has absolutely nothing to do with one on the right. They're just independent accidents.
And galaxies are the swirls in this analogy.
Exactly. In the standard model, a galaxy spin is just a stochastic accident. It's a fancy way of saying it's random. It spins because, billions of years ago, some nearby gas cloud pulled on it a little bit.
And this is the tidal torque theory, TTT.
That's it. That's been the reigning champion for 50 years. TTT says you spin because your neighbor pulled on you. It's called tidal shear.
That sounds reasonable, though. I mean, if I'm a cloud of gas and something heavy is next to me, gravity pulls on me, and I start to rotate, what's the problem?
It works perfectly fine on a local scale. The problem is distance. The source text calls it a systemic failure of TTT when you zoom out. Because gravity, well, it gets weak very, very fast.
How fast?
The math says the torque scales as 1 over r cubed.
Okay, hold on. So if I double the distance between two things, the force isn't just cut in half.
Not even close. You double the distance, the force drops by a factor of 8. You triple it, it drops by 27. It falls off a cliff.
So by the time you get past the edge of a galaxy cluster.
That twisting force is basically zero. The paper calls it thermal noise. It's just lost in the background static of the universe.
So under TTT, a galaxy here and a galaxy a billion light years away should have absolutely zero relationship.
Zero. They've never met. Gravity travels at the speed of light. They haven't even had time to feel each other's pull.
And yet the quasar data says they're aligned.
They're aligned. And the authors call this the final falsification. They're saying random models are dead. Local gravity cannot explain this.
So if it's not gravity, what is it? This is where the paper pivots, and honestly where my brain started to hurt a little. They introduce the Unified Chronofractal Field, the UCF.
Right, this is where we have to throw out the coffee cup analogy. We have to stop thinking of space as a fluid.
Okay, so what's the new analogy?
Legos, or maybe more accurately, a Lego base plate.
The green grid you click the bricks onto?
Exactly. Grimberg's team argues that the vacuum of space isn't empty. It's hardware. They say it has a discrete Lattice-14 Grid architecture.
Lattice-14? That sounds like something from a sci-fi movie. What does it mean for space to be a lattice?
It means space isn't smooth.
Yeah.
It's pixelated. It has a grain to it. Think about drawing on a blank sheet of paper versus graph paper.
Okay.
On the blank paper, you can draw a line at any angle you want, but on graph paper, you're sort of constrained by the grid. The UCF theory says the universe is a 3D grid with a built-in structure.
And how does that solve the distance problem?
They call it a distance-independent mechanism. I think the best way to visualize it is the floorboards analogy from the text.
Oh, I liked that part. So you're laying floorboards in a house, and they all run, say, north-south.
Right. Then you put a rug down and you line it up with the floorboards. Then you go a mile down the street to a different house built by the same contractor, and you lay down another rug aligned with those floorboards.
The two rugs are now parallel.
They're parallel. Not because they talk to each other, not because of gravity, but because they're both sitting on the same underlying structure.
The quasars are the rugs, and the Lattice-14 is the floorboards. They're all just plugged into the vacuum.
Exactly. And that's what the paper calls geometric inevitability. The alignment isn't an accident. The galaxies have no choice.
But this implies that space is doing something, I don't know, aggressive.
The paper uses a phrase that really stuck with me. Matter is screwed into existence. It's a pretty violent image, isn't it?
It sounds industrial, like a factory assembling parts.
It does. And this gets to the core mechanics of their theory. They're not just saying space is a static grid. They claim the vacuum is active. It has a refresh rate.
A refresh rate. Now we're definitely in computer territory.
They give a specific number, 12.84 hertz.
12.84. Okay, I have to stop you. That sounds so specific. It sounds like numerology. Why that number?
I had the same reaction. They derive it from their chronofractal mathematics, connecting the Planck time to macroscopic scales. We can't get into the whole derivation, but the implication is just wild. They're saying the universe pulses, it vibrates, 12.84 times a second. The vacuum updates.
So if I'm a cloud of gas collapsing into a galaxy,
You're being hit by this constant background vibration. The text calls it a phase torque. And as the gas collapses, it interacts with this 12.84 hertz refresh rate, and it creates what they call a hardware screw effect.
so my spin isn't coming from my neighbor, it's being imprinted on me by the vacuum itself.
Yes, the spin is just a local expression of the vacuum's own angular momentum.
They have an equation for this, equation 4.1. And you pointed out something really interesting about what's missing from it.
Right. Sometimes what's not in an equation is the most important part. In the old tidal torque theory, the equations are full of variables for mass. The mass of your galaxy, the mass of your neighbors.
Because gravity is all about mass.
Precisely. But in the UCF torque equation, there are no terms for neighboring mass. None. It only depends on the scale of the cloud, R, and the geometry of the vacuum. That's it.
Which is why it works over a billion light years. It doesn't care about your neighbors. You're not listening to them. You're listening to the floorboard.
You're listening to the lattice.
Yeah.
And that's why they're so confident this has to be the mechanism.
Okay, so it's a great story. Space is a grid. It has a refresh rate. It screws galaxies into alignment. But, you know, science isn't about stories. It's about proof.
And this is where that pre-data lock comes back in. They say there is a smoking gun hidden in the geometry.
They're looking for a specific angle.
A magic angle. If the standard model is right and spins are random, the axis should point all over the place. A flat line on a graph.
But if Lattice-14 is real,
then the spins should clump together. They should snap to grid. And the authors predict a statistical spike at exactly 54.74 degrees.
54.74, another incredibly specific number. Why not 45 or 90?
It's pure geometry. They're proposing a cubic lattice. So if you take a cube and you draw a line from one corner diagonally through the very center to the opposite corner.
The body diameter.
Right. The angle that line makes with the faces of the cube is 54.74 degrees. Mathematically, it's the arcsine of 1 over the square root of 3.
So if the universe is built of tiny cubes, things should naturally want to align along that diagonal.
That is the prediction. They say the universe has a snap-to-grid function, just like in design software.
But wait, there's a catch, right? You can't just look anywhere. If this grid is everywhere, why isn't our solar system aligned to 54.74 degrees?
That is the critical question.
Yeah.
And the document calls this forensic verification. It introduces something called the Einstein Lock effect.
Einstein Lock. Sounds painful.
It's all about general relativity. I mean, gravity.
Yeah.
In the universe, you have busy cities, the clusters, and empty deserts, the voids.
Okay.
In the clusters, it's crowded. There's so much mass, so much local gravity that it just overpowers the subtle signal from the lattice. The galaxies are all pulling on each other so hard, they drown out that background hum from the vacuum.
So the noise of the city drowns out the whisper of the floorboards?
Exactly. The signal becomes decoherent. So if you look at clusters, you'll just see random spins.
But Grimberg is saying, no, don't look there.
He's saying, go to the voids, the empty deserts.
The naked hardware.
I love that phrase. Out in the voids, there are no neighbors to push you around. There's no local interference. The only thing acting on a galaxy is the vacuum itself.
And that's where the 54.74 degree signal should be crystal clear.
That's the clean room. And they point out that previous surveys from Shamir between 2020 and 2024 actually did see alignment signals.
They did?
Yeah, they saw peaks around 52 degrees.
52 is pretty close to 54.74.
It is. Grimberg argues those surveys were just seeing anisotropy existence. They knew something was aligning them, but they didn't have the resolution to nail the number. They were seeing a blurry picture. He's betting Euclid will sharpen that image right to 54.74.
This really is a serious gamble. They've even laid out a falsification protocol.
Which is so rare. Scientists usually leave themselves some wiggle room, oh, the data didn't quite fit. Well, maybe there was some interference we didn't count for.
They moved the goalposts.
Exactly. But these guys explicitly state, no post hoc parameter adjustments are permitted.
Translation, no cheating after you see the results.
They've set a hard limit. For the final verdict, they require a sigma value greater than 3.0.
And sigma 3.0, for those of us who aren't statisticians,
that's a 99.7% confidence level. They're saying we need to be 99.7% certain that galaxies in the voids are aligning at 54.74 degrees, give or take 5 degrees.
And if the data comes back at sigma 2.5 or at 60 degrees,
then their theory is dead, falsified. They pack up their chronofractals and go home.
It's refreshing, honestly. It's binary. It's either right or wrong.
It is how science should be done.
So let's play this out. It's 2028. The Euclid data drops. We look at the voids, and bam, there it is. A massive spike at 54.74 degrees. What does that actually mean?
The source is pretty blunt. It says, the transition to the Unified Chronofractal Field marks the end of stochastic physics.
The end of randomness as a fundamental principle.
Yes. It means we don't live in a universe of happy accidents. We live in a crystal. A structured geometric lattice where order comes first, and matter is just a symptom of that geometry.
It flips everything upside down. We always thought matter tells space how to curve. This says space tells matter how to be.
It changes the vacuum from nothing to code, the operating system of reality.
That's what I've been thinking about this whole time. The language they use, hardware, refresh rate, snap to grid.
I think I know where you're going with this.
If the universe has a refresh rate of 12.84 hertz and a fixed pixel size in this Lattice-14 and a snap-to-grid function to, safe processing power?
It starts to sound a lot like a simulation.
It sounds exactly like a simulation. I mean, if I was coding a video game universe, I wouldn't calculate the individual physics for every distant object. I just write a script that says, if object is in a void, then align vector to 54.74.
It's a provocative thought for sure, and physicists have toyed with it for years. But this would be the first hint of physical evidence of the resolution limits of reality.
The resolution limits of reality. That is a terrifying and fascinating phrase.
It is. If we find this rigid structure underneath everything, we have to ask ourselves, are we discovering the fundamental laws of nature? Or are we just seeing the pixel count of the screen we're living on?
And if Euclid finds that magic angle, we might have to start asking who or what built the hardware.
And that's a question that goes way beyond physics. But for now, the test is simple. We just have to wait for the map.
Well, until that data comes in, thank you for taking this deep dive with us. We'll be watching those Euclid releases very closely.
It's going to be an exciting couple of years, no matter what.
Keep looking up, and maybe check if your rug is aligned with the cosmic grid. We'll see you in the next one.